Hey everyone, welcome back to my channel. My name is Oluwaseun, and today it's going to be a short lecture, and we want to discuss Terraform drift. Okay, and when we talk about drift, basically we're talking about a change in the actual state of your configuration or the resources that you have deployed. That is what a drift basically means. So if you look at the diagram that I have in front of me, you have your Terraform code, which is your desired state. You have your state file, which captures exactly what you have deployed in your environment. And then you also have your actual environment, right? Now, if you look at the actual environment that we have here, you would see here that the D actually seems like it is missing, which means the actual environment and what we have in the state file and what we have in the Terraform code are not the same. So there is what you will call a drift. Now, in AWS, there are two ways to actually detect drifts in terms of configuration. In the last video that I posted, I talked about the AWS config, which is also one of the services on AWS that you can actually use to detect if your configuration still remains the same or something has changed, right? And then of course you can use that to detect drift as well. But if you're deploying application through Terraform, right, you do Terraform init, Terraform plan. Your Terraform plan will show you the resources that will be created, after which you will now do Terraform apply. Again, Terraform plan can also help us to detect if there is a change in what has been deployed in our environment. Now, for example, which we're going to look at also practically, but I just wanted us to have an understanding of what Terraform drift is really about. Now, for example, say you created an S3 bucket with Terraform, and that S3 bucket has versioning enabled, and for some reason, perhaps let's just assume that somebody went into the console and then disabled versioning. Now, the next time you do Terraform plan, it's going to tell you that there's a change, which means there's what? A drift. So Terraform will look at it and say, this is the desired, this is the actual. All right, something is out of sync here. So the desired and the actual must actually be in sync. So if Terraform detects that, there is no synchronization between the actual and the desired state, then of course we can say that there is a drift. Okay, so how do we, use Terraform to detect this and then notify our team members appropriately so that they are aware that something has changed and then it needs to be corrected? And that is exactly what we want to do, all right, in today's video. So I believe that the explanation I've given us is clear enough to help us understand what drift means in the context of Terraform, and how we can actually solve that. So let's go over to the Anson section and see how we can do this. All right. So now, if you look at these folder, I have here a simple S3 bucket that I want to create just to, show us this Terraform drift. So here you would see here that I have, versioning enabled and all that, but we're going to go to the console and disable versioning. All right, and then run Terraform again and then see what this will give, all right, to us. So we're going to be leveraging GitHub Actions to deploy this, to make sure that we're going through the pipeline and all that. And I mean, we're not doing that locally. We're here to see how we can actually use this in a work environment, okay? Because in a work environment, you won't be doing it locally. You will have to use maybe GitLab CI or GitHub Actions, okay? So in this case, I decided to go with GitHub Actions to give us an idea of how we can do this with GitHub Actions, all right? So of course, I have a lot of videos already on GitLab, so I just thought, okay, let's do something with GitHub Actions, all right, today. So I'm going to come here. This is my plan file, my actions file that would help us to do, to create the resources. All right. And intentionally, I left these on workflow dispatch so that we could, go to the GitHub Actions page and trigger this pipeline. All right. So I intentionally leave that on workflow dispatch. But of course, there are different trigger types that you can actually use. Maybe later on we'll talk about those ones in future videos. All right. So what I'm going to do is I have already committed these into the repo, and of course we're going to be leveraging OIDC here as well. I'm not going to be showing you the OIDC thing, but of course we're going to be leveraging that. But in another video, we'll talk about how to set up your OIDC and how it differs from GitLab CI. But for now, let's just understand what we have. So here we're using the workflow dispatch. So we're going to be triggering this manually. That's what it means. And of course, we have two choices. We have input here. So which means our users can decide whether they want to apply or they want to destroy. Okay. And the input is basically used to make decisions, all right, as to what should run and what should not run based on the input that the user, all right, chose or, selected. So if you scroll down here, now because we're using the OIDC, all right, we have to include this to it, permissions, ID token, write, content read. So it's going to be able to read the content and it's going to be able to, all right, generate, token to authenticate with AWS. Okay. And of course, the working directory is S3 because we have these in a folder of its own. So we have to specify the working directory. Okay, and then we have the steps. So we're using the checkout, all right, version 5 actions. One thing with GitHub Actions, for those who may not be familiar, or maybe you don't have, perhaps you have a limited understanding of GitHub Actions, right? It uses what you call actions, right, which are things that you can get in the GitHub Actions marketplace that you can use to run your workload without necessarily, writing shell commands and all of that. Okay. So here we use the checkout actions, and of course we're using the AWS action as well. But in this case, we're not using the access key and secret key. We're basically leveraging the OIDC configuration. So what we need for OIDC is basically a role. Like I said, in a future video or maybe later video, we'll talk about setting up OIDC with GitHub Actions. Okay, we've talked about that with GitLab CI/CD, but later, like I said, we're going to do that with GitHub, all right, Actions. But for now, just follow what I'm doing. And so here we're also using the HashiCorp actions, right, which will make it easy for us to run the job. Okay, to do our Terraform init, Terraform plan, Terraform validate, and all of that. So now the input that was specified under the workflow dispatch, this is where we use it. So if we look at what we have here, we have if github.event.input.action not equal destroy, which means if the user did not select destroy or did not choose destroy, then the Terraform plan should run. All right, and of course create a plan for us and do all of that. And another thing here is that we're also using the upload action as well. So this is going to upload the Terraform plan log file. All right, it's going to upload it as an artifact that can actually be downloaded. All right, that we can actually see what it intends to create on AWS. Okay. And another thing that I've included here for us also is that we can actually send an email to our team members to let them know that, okay, I'm running a pipeline and this is what, will be created. They can take a look at that, take a look at the plan, see the number of resources that will be created and, take action as necessary. All right. Okay. But of course, you can also put an approval stage so that it doesn't just apply automatically. So there can be some kind of approval where if the plan has been reviewed and everything is fine, then they can approve, all right, the apply. So the apply is going to be more like a manual kind of apply. So there are ways that you can do that. Okay, we're going to look at those in later video. Okay. So we have all of that. So here, this Python script, which is available here under script. So you have this script right here. So this is the script that was responsible for sending out emails. So once the plan, job is done, it takes the plan file, right, reads the plan file, and then sends that in TXT format as an attachment to the recipient. So they can download it as an attachment, read the content of it and see the number of resources that will be created or Terraform intends to create, and then approve or maybe give their comments as the case may be. All right, so that's the purpose of this. So I added that. And of course, I also added the fact that you can actually also create a CloudWatch log that can capture this plan output as well. Okay, so you can go to CloudWatch and review the plan as well. So I just thought to add that, for us as well. So if you look at this Python script, that is what that is doing as well. So this is not a Python class, so I won't be walking you through all of this, but just know that with Python, you can actually create, some of these things, very easily, leveraging the Bodo 3 SDK. All right. So, and here also, you can also see the upload plan file and all that, and then the apply job and the destroy job. We can see all of that right here. So what I'm going to do is that I'm going to push this into the repo, and then we're going to run the workflow and see what this will create. So for the apply job as well, it will also send out the outputs. So whatever it is that was created, the outputs, all right, that will contain, the attributes, references, right, will also be sent out to the team members as email, so they can actually see what was created, all right, the values and all of that. Perhaps, for example, if you have a jump server created, if you have a database created, the database ARN, the database name, all those kind of things will form the output, and then you can send that as email. Okay, also, so that's what we're doing here as well. So there's another script, all right, for that. So which is what we have here as well. So you can actually leverage the script in your own environment as well. So that's what we have right here. Okay. And of course, for the destroy job, if the user chose destroy, then automatically it's going to skip plan, it's going to skip all of that and just basically destroy what needs to be destroyed. So let's push these to the repo. And let's run this. Remember, the purpose of what we want to do today is to see Terraform Drift in action. Now, if you look at what I have here, you will see that I have 3 action files. So one is for Terraform apply, and the other one is for the drift check, which is the one we're actually going to use to detect, that there's a drift in our environment. Okay. So of course, you can have as many action files as you want within your GitHub Actions page. That is allowed. Okay, so let me commit this and let's trigger this workflow, because I intend to make sure that this video is short. It's very short, as short as possible. All right, so I'm just going to say TF apply, and let's push that to the repository. Okay, good. So we pushed it. Remember, this is going to be a workflow dispatch. So I'm going to come right here, all right, to this place. Okay, so I'm going to come to actions, and don't forget also that all the variables that we have defined here, you must have stored them under your actions, under the secrets, which is here. You select actions, and then you can find all of those here. So there's the secret, the role area, and then the variables. You can find all of them right here. Okay, so I just thought to show you that. So let's go back to actions. We're going to come here, Terraform apply and destroy. We're going to click on that. And I'm going to come here. And as you can see the input. So I can either choose apply or destroy. So I'm going to say apply, and I'm going to click on run workflow. So that's going to trigger this particular workflow, and it's going to try to do the Terraform plan. So let's see. So Terraform plan is running. Terraform plan, the apply job and the destroy job is dependent, all right, on the Terraform plan, or basically they are separate jobs, right? If you look at it here, but it's still dependent. You can see needs plan, right? So it's dependent. So plan must run successfully before the apply job will run. So you can say the Terraform plan, all right? So it's telling us it's going to create 4 resources, all right, and all of that. And then you can see here that it's trying to send out the email, all right? And then it says here that the email has been sent, all right? And of course, behind the scene, I'm leveraging SES behind the scene, all right? So if I go to my email here and I do a refresh, the email will come in any minute from now, all right? So the plan job is done, and of course, the apply job will start, immediately after the plan job, right? So let's see. And this basically is just going to create the resources, right? Create the S3 bucket and nothing more, all right? But we're going to look at the drift now, how we capture drift, all right, with Terraform. So you can see the resources have been created, and the same thing also is going to send out an email that contains, all right, the outputs, all right, of what has been created. Okay, so if I look at my mail, you can see the plan review here. So you can see the mail, Terraform plan review, da, 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 da. So here you can actually download this and see. So if I download this, I can download this in my downloads. I can open it up, and right here you can see the text file. So you can see the text file. So the apply job, there's actually a way you can actually pause the apply job, and wait for approval. Okay, there's a way to do that, which I'm going to share with us in a later video. Okay, so that it doesn't just do Terraform plan and then automatically start applying. No, because I mean, somebody has to review this plan, right? What if this is not what we want to create, right? And then Terraform apply as run, right? So we need to, we can look at that as well. So this is the text file that was sent to the mail. And of course, if maybe the team lead or whoever is okay with this, they can send an email to the team and all that and say, okay, the Terraform plan is okay, and you can go ahead and all of that. And then of course you can see the apply. So the output.json is here, so I can download that as well. All right, I can download that, and then I can open that also, and then you can see the values here. So this is the bucket ARN, and then of course the name of the bucket that has been created, right? So you can see that everything comes into the email. Okay, so that's that about that. Now, what we have done basically here is just, it's something that quite a number of us are familiar with, right? You can do Terraform plan and all that, but what we are really interested in is how do we check for drifts? How do we check that, right? How do we check that? Now, one thing about Terraform plan is that it has what is called a detailed exit code. All right. Terraform plan has an argument or option that is called detailed exit code. Now, let me show you what that means. All right. So if you come here and you do Terraform, all right. So let's do Terraform plan. Okay. I'm gonna get an error, but let's try to do that. Let me see the credential I'm using first of all. So AWS configure list. Oh, okay. All right. So I'm using the correct credential. So if I do Terraform, let me do Terraform init first. Okay. I need to go into the S3 directory. All right. Good. So let me do Terraform init. Let's see what we have. So now, right now, of course, there's no drift, right? Even if I do Terraform plan, it's going to tell me nothing has changed, right? No changes to your infrastructure and all of that. Okay, but how do we detect the drift? How do we, get the message and all that? So now, if I do Terraform plan, it's going to run through the whole infrastructure, tell us that, okay, nothing has changed. Your actual state and your desired state are in sync, so there's no changes, right? Now, look at what it says, no changes. Now, if I go over here to the console and I go to the S3, right? If I go to S3 here, okay? So if I go over here to S3, let's quickly see that. We're going to see the bucket. So this is the bucket that has been created. So you can look at the time here and the date. It was just created. So if I click on this, I can see it here. So if I come to properties, I can see the versioning is enabled. So if I edit this, I can suspend versioning, and that would cause a drift, right? So I can do that. Now, if I go back here and I do Terraform plan again, all right? So now it's going to detect a drift. Okay, but there's something that I want to show us, which is going to be helpful in our pipeline. Right now, look at it. It says here, one to change. So that means there is, something that has changed since the last time the configuration was applied. Now, let's look at these. So if I do Terraform plan hyphen help, hyphen help, I want to show you something. Now, if you look at the argument that you have here, or the options you have, there's what you call detailed exit code, which means when I do Terraform plan with the option detailed exit code, there are 3 exit code that Terraform emits, right? The first one is 0, which means succeeded, there are no changes, which means nothing has changed. The second one is the error code, the exit code 1, which means there's an error somewhere. The third one is exit code 2, which means it succeeded, but there is a difference. Can you see that? There is a difference. Now, this detailed exit code is what we need to detect drift in our pipeline. And also, when you do Terraform plan, you need to include this detailed exit code. But how are we going to capture the exit code? How do we do the capturing? Right? How do we do that? So let me show you how we can do that and how we can use that to detect whether there's a drift. And if there is a drift, then we should get an email. If there's no drift, which means if the exit code is 0, it means there's no drift. It means nothing has changed. But if the exit code is 2, it means that there is a difference, all right, between the desired state and the actual state. And that should trigger an email notification. Okay, so let's see how we can handle these in, all right, our pipeline. So let's see how that can be done. So I'm going to come here to the drift check, the YAML. So if you look at what I have here, now, one thing that you can also do is to enable, all right, the schedule trigger. Because you're not going to be going to your GitHub Actions every day to trigger your pipeline or your workflow manually, but you can actually trigger it on schedule. I mean, maybe 9 a.m. every day, right? Of course, it's not going to be 5 minutes. What I have is 5 minutes, but you're not going to be doing that every 5 minutes, right? That's going to, it doesn't make any sense. But you can say, okay, every 8 a.m., 8 a.m. every day, right? 9 a.m. daily, 10 a.m. daily, okay, on schedule, just run, and then send us the notification, all right? And then it runs at 8 a.m., send you the notification. If there's a drift, you get an email. If there's no drift, you don't get an email. Okay? So on schedule is actually one of the triggers that you can actually use to automatically trigger your workflow, particularly for things like this. Okay, so I'm going to leave that at 5 minutes, and I'm still going to leave the workflow dispatch so that we can actually trigger this manually as well. So I'm going to leave that. So let me show you something. So it's pretty much the same thing. The permission and everything is the same. But what I want to show you is this. Now, this particular option, Terraform wrapper equals to false. Why is it needed? It is needed because we want to capture the raw exit code, all right, of Terraform. We don't want that to be eaten away. We don't want that to be wrapped away, right, and then not exposed to us. Okay, we want to be able to capture the exit code and determine whether Terraform succeeded with, all right, with the exit code 0, which means no changes, or Terraform succeeded with exit code 2, which means there is a difference. So the Terraform wrapper equals to false, we need it actually, because for example, now let me show you something. If I come here and say I remove it, let's see what will happen if I remove that option, right? Remember, there is a drift, right? We've disabled versioning, so there's a drift already. All right, so now let's apply this, and what we have here is this. So we said here, set E, Terraform plan, no color, detailed exit code, all right? And then of course we're outputting out the plan and all of that. And then exit code equals to $question mark. $question mark basically would give you, if the last command you run successfully, then it gives you 1. Or if it fails, it gives you 0 rather. If it fails, it gives you anything that is greater than 0. So what we need this for is to capture, all right, the exit code of Terraform. What code did Terraform exit with? Did it exit with 0? Did it exit with 1? Did it exit with 2? So if it exited with 2, then we know that, okay, there's a difference. If it exited with 0, we know there's no difference. And that is why we included this particular option here to capture the 3 exit codes. So, I mean, either of the 3 will be true. It's either it's exited with 0, 1, or 2. But we need to capture that. So because if we are able to capture that, then it will be easy for us to determine whether we want to send an email or we don't want to send an email. So for example, here now, this particular job or step is saying that if the steps, the drift, the output, the exit code equals to 2, then of course an email should be sent. But if it is not equal to 2, of course, that's not going to send an email. All right. So let's see how this will go. So I'm going to do git commit. All right. So let's just say exit code. And then, of course, let's push the changes. Of course, we have it scheduled, right? So 5 minutes, right? But then we don't want to wait for that. So I'm just going to come here. Perhaps, I mean, while we're doing this, 5 minutes might meet us here and then it triggers automatically. But for now, let's run the workflow manually. Okay, and let's see if we're able to detect the drift and send out an email, all right, accordingly. Now, these particular, all right, file here for the drift, it's only going to do Terraform plan. It's not going to do Terraform apply or anything. It's just going to do Terraform plan. And that is why it is good if this particular workflow file can be run on schedule, right? 9 a.m. daily, 10 a.m. daily, 9 a.m. on Mondays, and all those kind of things, right? So basically, you don't touch it. It's basically scheduled. At social time, it runs and then it sends out the information as necessary. Okay, so let's take a look at what it's going on here. It's quick. So we can see here that it says this was run manually, and of course 1 minute ago. So if I click on this, we can see what we have. So let's see what this gives us. So I'm going to click here. So now, if you look at what we have, if you go to Terraform plan, which is what should detect the drift. So let's see what that detected. Because already we can see that the send drift detected email was not run. The log drift to CloudWatch was also not run, but no drift detected actually ran. So that means it's telling us that it didn't detect any drift. Remember that I removed the Terraform wrapper. So that might be why we have this challenge. Okay. So if you look at what we have, really, there's actually a drift because there's a change. Okay, but if you look at the exit code here, it says Terraform exited with code 0, which means it succeeded with no changes, and which is not true, because right here we can see that there is actually a change. Okay, there's actually a change. And then you can see here it says no drift detected, which is not true, right? And that is the Terraform wrapper's default behavior. Right? By default, when you're using the Terraform action, the Terraform wrapper is set to true by default, which means it hides the Terraform exit code. Okay, so that's why we need to make it false so that we can actually capture the correct Terraform exit code. Is that okay? So let's go back and let's put that back, because if you look at what we have here, this is a change, but it's telling us it exited with a 0. And we know already that 0 means it succeeded without a change, but 2 is actually what it should give us because there is actually a difference. So let's go and resolve that. So I'm just going to come back here and return the Terraform wrapper. All right. And we're just going to do the push again. All right. So we can call this Terraform remember our pipeline is scheduled for every 5 minutes. So we have our Terraform push, it's gone. So let's go over here. So let's go and trigger the workflow again. And let's see what this will give us this time around. So I'm going to come back here. Let's see what this will give us. So you can see here that we didn't get any email that there was a drift that was detected. I mean, that's because, there was no drift detected because of the wrapper. All right. So let's go back and let's trigger the workflow again. All right. So let's do that manually. All right. So let's run the workflow. And if you look at the email, we didn't get an email. If you look at the log groups, let's see if the log group was created for the previous one that we did. So for the previous one, the apply and the plan, you can see here that we have the log group, and indeed something was logged, right? If you look at it here, you can see the plan file, all right? So the plan file was logged in CloudWatch, all right? So somebody can come here as well and see what this is, but of course, email, Slack, those are a bit more convenient than coming here to see what is going on. All right, so let's see. So, all right, the Terraform drift has been triggered again. So this time around, we should get an email, right? So let's click on it and let's see what this gives us. All right, look at that. Send detected, and then of course, I logged it into CloudWatch. Can you see that? So if I come back here to plan, if I come to plan, now the exit code should be captured properly, right? Not defaulting back to 0 like it did earlier. So you can see Terraform what? Exited with a state with a code of what? Of 2, which means it succeeded, yes, but there is a difference. Is that okay now? So that is what we expected. And you can see that, an email was sent out. Then, of course, the log was also sent to the CloudWatch. So if I go back to CloudWatch now, and I go to log group and I refresh this page, all right, there should be a log group that has been created. So the log group has been created for drift. And if you take a look at it, you would see what configuration changes, all right, that needs to be applied. So the purpose of this is to get the information across, let them understand that there's a drift, something needs to be done, and then they do it. So if you come here, you can see the email and it says Terraform drift detected. Can you see that? Terraform drift detected. Drift detected in the Terraform managed infrastructure. Right. Review the plan, and of course, let us know what needs to be done. So if you look at it here as well, you can see the drift right in CloudWatch. Okay. So I did mention to us that you can actually run your pipeline on schedule. Okay. If you look at what I did there, this is every 5 minutes. But what you will realize is that if you check the repo, for example, you can see that this ran 24 minutes ago, 25 minutes ago, and this ran just about 2 minutes ago. So you can see that it's not really, every 5 minutes as you would think. But of course, you don't want to run your pipeline on schedule every 5 minutes, right? It probably will be maybe 9 a.m. daily or 9 a.m. every Monday. All right, but I just did this to demonstrate to us that you can actually run your pipeline on schedule, which is actually the way to detect drift and then send out emails or notification to those who should, check things and approve things and all of that. And of course, if you look at the mail, because I left it, to run on schedule, right? You can see that my mail is full already. Okay, because I intentionally left it so that you could see. But what I wanted us to see also is that the 5 minutes too, it is not really 5 minutes, right? In some instances, it's 5 minutes. In some instances, it's more than 5 minutes, right? So, but again, it has to be daily or weekly, depending on your own use case. But I just wanted to demonstrate to us that you could run your pipeline on schedule. And for Terraform drift check, running it on schedule is actually one of the ways to do that, and then send out notifications to the intended recipient so that they could see what has changed and what needs to be done and all of that. Okay. So thank you. So that's pretty much how you do Terraform drift. All right, you detect drifts in your Terraform configuration, and then you can remediate it accordingly. Okay, so that's what I thought to show us in this video. Like I said, I don't intend for it to be very long, but I believe that with the explanations and with the practicals that we've done, you have gained a thing or two. And of course, in the next lectures, I will talk about the OIDC and how you can also do approval and all this kind of stuff. Okay, so thank you so much. I'll see you on the next one. Bye for now.